Hi everyone. Um, Today is our first lesson for geometry. Um, these are the cases I want to explain. Maybe in the subsequent videos, then we'll start solving problems. So if you want to understand all of these ones, so this video is for you. Um, Definition of angles, types of angles, basic theorems like the adjacent angles, vertical opposite angles, notation in geometry, parallel lines, transversal line, perpendicular lines. What are the angles generated when we have a transversal line? Um, Three key summary points about acute, obtuse, and both acute and obtuse. Then what if the transversal line is perpendicular to the parallel lines? So this video is very much important. Of course, so many people, so many students, they always have too much fear of angles. Once they see the diagram, once they see angles, of course, they are confused. So pay attention and make sure you go to the comment section and ask whatsoever question you feel like asking. All right. What do we understand about angle? When we talk about angle, what does that mean? Sometimes when I teach beginners, I usually say an angle is like when we say go and stand at the corner, like the word corner. But in geometry, in mathematics, when we talk about angle, it's a specific opening, it's a specific space that is covered by straight lines. For example, if we have a wall like this, and this is the floor, of course, it is horizontal, and the wall is always vertical. So this space that is formed by the wall, the vertical wall, and the horizontal floor, this space is what we mean by an angle. So any space that is formed by two straight lines meeting at a point, that space is what we mean by the word angle. So once they say angle, think of a space. Yeah. Now this one is a straight line. Here is another straight line. This straight line and this straight line, they are not like this. They meet at a particular point. They meet at a particular point. So when these two straight lines meet at a particular point, they form a space. Yeah, we can say right from the positive x direction, then it goes which way? Anti-clockwise. So it means it opens like this to this point. So this space that is formed by these two straight lines, this space is what we mean by the word angle. Mostly we use Greek alphabet to represent angles. We can as well use the English alphabet like the A, the B, the C, the X, the Y, the Z, all of them. They are entitled to representing angles. But mostly we use Greek alphabet like theta here. Yes, like alpha. Yeah, like beta. We use all these symbols. We use all these Greek alphabet to represent an angle. So once they say angle, think of what? The space that is formed when two straight lines meet at a point. Now, this point where the two lines meet in order to form the angle, this point is what we mean by the word vertex. So once you hear the word vertex, vertex is the point where the two lines meet to form an angle. And these lines that meet to form the angle, we have a unique word. We say ray. Yeah, this is also ray. So in plural, just add s to say rays. But vertex, the plural, you don't just add s. Yeah, you replace the ex with ices. So vertices, something like that. Vertices. So the point where the two lines meet to form an angle, that point is called vertex. The space formed by two straight lines is what we mean by the word angle. So an angle is amount of rotation or what or revolution. So when it revolves, when it is open like this, when it rotates, yeah, let's say from the positive x-axis, it moves like this. At some point, that space that is formed is what we mean by the word angle. Yeah, so this is angle for you. Okay, so the next thing is how do we get angles? Do we manufacture them? Do we create them? Angles are constructed. Angles are what? Are constructed for accuracy. We don't usually draw to get angles. Yeah, geometrically. Because if you are having a line, this line could not be perfect. Yeah, so therefore, angles are constructed. What do we use to construct an angle? We use two instruments, two items. We use what? A pair of compasses and what? A pencil. You're supposed to know what, okay, let's say we have this. Yeah. So here is where we insert the pencil. Yeah. So here is the sharp point of the compass. Yeah. So this is okay. So this is a pair of compass. Don't mind the accuracy of the diagram. This is a pair of compass. Then use what? A pencil. So we use this one what? To construct an angle. Like this a given line. Then you can use this one to have an arc. Here is another arc. At this point, you can open it like this. Then here, then you cut the arc. Yes. So we have what? Our angle here. So angles are constructed using a pair of compasses. Then how do we use to measure angles accurately? We use what? A protractor. Of course, it's a semicircular shape ruler. Yeah, of course, you can see here like 90, 30, 60. It's like this. All of these instruments, we usually get them where in the geometric set. Yeah, geometric instrument. So this one is a protractor. We use a protractor to measure angles. We use a pair of compasses to construct angles. Then angles, just like when we say currency, we have units of currency. We have leons, we have naira, we have cedis, we have dollars, we have different ones. So likewise, angles are measured in degrees. So when we say 40 like this, it couldn't be that meaningful until we have a small zero at the top hand right of the number. So this one is read as 40 degrees. Yes, we can say 30 degrees. We can say 80 degrees, 120 degrees, to name but just very few. So this symbol is what we mean by degree. So angles are constructed using a pair of compasses and a pencil. Angles are measured using what? A protractor, and angles are measured in degrees. So the definition for angle is the space formed when two straight lines meet at a point. That point is called vertex. The lines are called rays. Okay, so we are done with the definition. Now let's go to the types of angles. We have so many types of angles, just the basic ones we want to define here. Now let's say basically angles are measured from the positive x-axis. Yeah, of course, this is the x, this is y. So basically, angles are from the positive x-axis. And which direction do we go? Anti-clockwise. You know, the clock goes like this. So whatsoever that goes against is anti-clockwise. Okay. Now, since here is the beginning, so we can say at this point before making any rotation, before making any revolution, before making any movement, we can say this point is 0 degrees. 0 degrees. So when this angle keeps moving, we can have like 5 degrees, yeah, 20, can have 45, can have 60, can have 80, then it gets to 90. Yeah, mostly for accuracy, we indicate zeros. So this is 0, 5, and so on, and it gets to 90 degrees. So it keeps moving. Let's say there is 98, 120, let's say 160, 178, and here is 180 degrees. So it keeps moving again, 185, yeah, let's say 200, 250, 260, then it gets to 270 degrees. Then let's say 280, let's say 300, let's say 348, 355, then it gets to 360 degrees. Now, we want to discuss types of angles. We want to discuss the types of angles. So to start with, when we define angles, basically, we consider range. So between 90 and 0, something like this. Mind you, between, excluding 0, excluding 90, between 0 and 90 is what we call acute angles. So that tells you that if the angle is 1 degree, it is an acute angle. If the angle is 60 degrees, it is an acute angle. If the angle is 89.9999, it is an acute angle. If it is 45, 48, 70, all of them are acute angles. An acute angle is an angle that lies between 0 and 90 degrees. Okay, what if the angle is exactly 90 degrees? If the angle is exactly 90 degrees, we call it right angle. How do we call it? Right angle. This symbol means angle. Okay. An acute lies between 0 and 90 degrees. And if it is exactly 90 degrees, we call it what? Right angle. So whenever you hear the word right angle, your math teacher says right angle, think of what? 90 degrees. Okay. So when we are discussing types of angles, some is a range, some are exact. Now, between 90 and 180, between what? 90 and 180. Between 90 is excluded, 180 is excluded. Between, this one is an obtuse angle. An obtuse angle. So how do we define right angle? A right angle is an angle that is exactly 90 degrees. An obtuse angle is an angle that is between 90 and 180. Between 90 and 180, they are not inclusive. They are excluded. So it tells you that 91 is obtuse, 98, 100, 150, 160, 110, 105, 178, 179, 162. All of these ones are obtuse angles. So the way you see the acute like this and this, now look at the points. An acute is between this. That tells you that acute can be like this. This one is an acute angle. See? In fact, the word acute means sharp. Sharp. You can say this one is an acute angle. So this again is acute because it is less than 90. So even if it opens like this, it is not yet up to this 90. So it is still acute. So remember, an acute angle is less than 90, between 0 and 90 degrees. So how about right angle? This is right angle. Only right angle that is unique with this symbol is square box. Yeah. So whenever you see a square box, do not even wait to see the number 90. Claim that this one is a 90 degrees. Yeah, claim that this one is what? 90 degrees. Hence, it is what? A right angle, because of only right angle has a square box like this. Right angle. So the obtuse travels all the way from 0 and it opens this way. So therefore, this one is an obtuse angle, because between 0 to 90, it is way more than that. Look at the level of 90. See, 0, 90, and it goes beyond 90, but not up to 180. So this angle is what? Is an obtuse angle. It is greater than 90, but less than 180 degrees. So what if the angle is exactly 180 degrees? So this one is a straight angle. You can call it straight line angle, or you simply say what? A straight angle. So a straight angle or straight line angle is exactly 90 degrees, something like this. So we don't have a specific angle name between what? 180 and 270. We don't have a specific one between 180 and 270. We don't have a specific one between 270 and 360. But what? Between 180 and 360, between 180 and 360, that is what we call reflex angle. Yeah, we call it what? Reflex. Reflex angle. So if something starts from 0 here, it goes like this, even if it stops here. So it will go like this. See? So this one is a reflex. So what I want us to understand here is, when you see a reflex angle, it appears to be like what? An obtuse angle, because look at obtuse like this. So in a standard form, we don't like having angles like this without indication like this. So even if it appears like this, if it is from inside indicated, this is not a reflex. This is what? An obtuse angle. This is obtuse, this is obtuse. So if when this one stands like this, if the indication is from outside, well, this one is a reflex. A reflex. So we need to understand all that. Yeah. So likewise, this one is acute. Yeah, this one is acute, provided if it is indicated, the angle is indicated inside. But if you have it like this and it is outside, it is said to be a reflex angle. So how do we define a reflex? Reflex is between 180 and what? 360 degrees. These are what we call reflex angles. Acute angles, right angle, obtuse angle, straight line angle, reflex angle. Okay, now let's go to basic theorems. Let's go to basic theorems. Okay, adjacent and vertically opposite angles. This one is a straight line. Okay, let's call this angle X. Let's call this angle Y. Okay. Now, angle X is formed by these two lines. Angle X is formed by this line, and they meet at this point. Angle Y is formed by this line, and they meet at the same point. So when we ignore Y, we have X. And if we ignore this line, we have Y. So what you can sense here is, this is the meeting point when this angle X is formed. This is a meeting point when angle y is formed. So we can deduce that this point, which we call vertex, it is serving this angle. The same vertex is for angle y. So in geometry, whenever two angles share a common vertex, we say the angles are adjacent. We say the angles are adjacent angles, because adjacent angles, they share a common vertex. Adjacent angles, they have a common vertex. This is the vertex for x, this is the vertex for angle y. So the fact that these two angles, they share a common vertex, we can say they are adjacent. They are adjacent. So what is the theorem now? The theorem says adjacent angles, especially adjacent angles on a straight line, you see, there is a line that covers both the adjacent angles. So we can say they sum up to 180 degrees. So this tells us that angle x plus angle y is equal to 180 degrees. Yes. For instance, if the teacher gives you like 120 degrees and the teacher says, find the value of angle x, what should come to your mind is angle x and angle 120, they have a common vertex. And there is a theorem that says when two or more angles share a common vertex and are covered by one specific line or on a straight line, we can say they sum up to 180 degrees. So you can say 120 degrees plus x is equal to 180 degrees. Y equal to 180 degrees is not something that I decided to say. It's not something that you decided to say. It's something we call a theorem that says adjacent angles on a straight line sum up to 180 degrees. Sum up to what? 180 degrees. Okay. Then you can go on with algebra and find the value of x. Now let's go to vertically opposite angles. Vertical angles or vertical opposite angles. Okay. This one is a straight line. This one is a straight line. We have two straight lines. They cross each other. And the mathematical term, when lines cross each other, we say what? They intersect. This line intersects this and this one intersects this. So they cross each other. When two straight lines cross each other or they intersect, the angles that are opposite to them, we call them vertical angles or vertical opposite angles or vertically opposite angles. And what the theorem says about vertically opposite angles, the theorem says that vertically opposite angles are always equal. So if you have your angle P and here your angle Q, do not hesitate to say angle P is equal to angle Q. Why are they not summed to 180? Because the theorem is saying whenever angles are vertically opposite, they are said to be equal. Let's say we have here y and here is z. So we can say y is equal to z. Why? Because they are vertically opposite angles. But likewise, we are discussing vertically opposite angles. We can as well detect what? Adjacent angles here, because angle P, this is the vertex. Angle Z, this is the vertex. So these two angles, they do not only share a common vertex, but they are also covered by what? Straight line. This line covers these two angles. At the same time, the two angles share a common vertex. So we can conclude that P and Z, they are adjacent angles. And on a straight line, so we can say P plus Z equal to 180 degrees. Do not say because we are discussing vertical, we expect what to see P equal to Z. No, P and Z, they are what? Adjacent angle on a straight line. So adjacent angles on the straight line sum up to 180 degrees. They sum to 180 degrees. Whereas vertical opposite angles, they are equal. They are equal. Here they sum to 180. Here what? They are equal. So P and Q, they are opposite. Y and Z, they are opposite. So therefore, Y and Z, vertical opposite angles, the reason they are equal. P and Q, they are vertical opposite, the reason that they are equal. P and Z, they are what? They are adjacent angles on a straight line. They sum up to 180 degrees. So let's go to notation. Let's go to notation. Some people are confused by the notation in geometry. We have like angle, triangle. Well, angle, this is a symbol for angle. Yeah. So when you add S, we say angles. Triangle, this is a symbol for triangle. When we add S, we say triangles. Yeah. So the notations, of course, they are very much important. Now, let's say we have a triangle like this and labeled A, B, C. They want to discuss this angle. This angle is formed by two lines, this line and this line. They meet at this point to form this angle. So this angle is formed by this line and this line. So what are the letters involved? A, B, C. Can we call this angle ABC? Can we call this angle BCA? Can we call it ACB? Let's find out. The angle is situated where? At B. So only this one is accurate. We want to talk about this angle. It is located where? At B. So B has to be at the middle. It has to be between the two letters. So you can call this angle ABC or you call it angle CBA. What is compulsory here is B has to be between the two letters. So now how do we write it? We can write it in three ways. We can write it this way in notation, angle ABC. What is the other way to write it? We can write it with this cap at the top. This is angle ABC. What is the other way to write it? With a single letter, angle B. It is also accepted this way, angle B. So when you see this one, angle B, this is angle B. This is a single letter format. This is a three letters format. That is ABC, this one, or CBA. So this is how we write angles. But it is conditional for us to use this one. It is conditional. Now let's say we have another line here. Yes, let's call this one D. So in this case, you cannot just say angle B. No. Because B does not only represent this angle. This B stands for three angles. This B is representing this angle. This B is representing this angle. Finally, this B represents this angle. So now let's say we want to identify only this. Only this. So forcefully, you must use the three-letter format if you want to identify this. This letter, where do we start to write this? Let's start with B. So where are the two letters to write with? This angle comes from C, comes from D. See, this angle, B is at the center. But what do we write here? What do we write here? This angle B comes from C, comes from D. So we call it CBD. If you want, you can say DBC. The most important thing is the letter where the angle is situated has to be at the middle. So now you can choose to either use this format or use this format. But I want to use this single letter format here. What do? I want to use the single letter format here. What do? Well, the only way I can use the single letter format, I have to inform the examiner. I have to inform the teacher that, for example, in triangle, if I want to use the single letter system, so I have to identify the triangle I'm working on. I can say in triangle CBD, in triangle CBD, then I can say angle B. So the teacher cannot think of angle B to be this. The teacher cannot think of angle B to be this because I have informed the teacher, I have informed the examiner, marking my script that in triangle CBD, then if I say now angle B, definitely it means this one. So these are critical points that sometimes make people confused. Students get a lot of confusion when doing geometry. But with time, you will get everything you need to understand about geometry. Then again, how do we write a triangle? Identifying a triangle, like here when I said CBD, triangle CBD. When identifying a triangle, you have the right to start anywhere. I may say what? Triangle CBD. A colleague of mine, a friend can say triangle DBC. You can say triangle BCD. When you are identifying a triangle, any form, any order use the letters, it doesn't matter. Only when identifying angles. Okay, so we can have another video for the remaining part so I don't take much of your time. So thank you for watching. Don't forget to like, share, and comment. Bye bye.